0.037 divided by 4 raised to the 4t. That's going to be the amount at time t, and that's going to be after 7 years, a of 7. And let's say we're approximating here, because I'm going to say, 0.037 divided by 4. I could do that in my head, but yeah, that was easier. Add 1, and I've got the base. Okay, so that's in fact exactly, I guess, 1.0395925, 00925. Okay.
It's 12,000, not 1,200.
Oh, 12,000. And then 4t. So a good thing to do at this stage is say, well, what's your effective annual interest rate? So we can say, give me this number raised to the power 4. Then I've got, this is 12,000 times 1.0375. Do I want more digits? Do I care? 16548. It's got a lot of digits here. To the t, right? So first apply the exponent 4 to see, well, an annual interest rate of 3.75% compounded quarterly, just a little bit more than 3.75%. Or sorry, 3.7% becomes 3.7516 and change, right? Okay, so now, I want to say 7, right? I'm plugging in 7, I said, so I should stick with that. So now I'm going to, the order of operations says first raise that to the 7th power, then multiply it by 12,000, and you'll get the number here. Can we copy this? Let's see. And paste, yeah. Save myself the trouble of remembering what it is. So 15,529. Resistance is futile. Oh no! Round to the nearest penny. So they were looking for a 1 in that spot, huh? Sometimes you get away with not rounding. In this case, they wanted us to round. Okay. You never know. Okay, so that's pretty straightforward. Let's move on to the next bit, which is 4.2, the natural. Okay, so here we have some data, and for each table below, could the table represent a function that is linear, exponential, or neither? So in the first one, we're looking at rate of change. X is steady increments of 1, right? Then y goes down 16. Then y goes down, what? Less than 16, goes down like 12.8, huh? And it goes down like 10 point something, right? So the amount of decrease is not steady. X is increasing steadily, but y is not decreasing, so it's not linear. Is it exponential? Well, you can always figure out b. So we're assuming, b to the base, right, of the exponent. So we're going to assume that if it's exponential, then it has this basic form, right? So f of 2 divided by f of 1 is going to be a times b squared divided by a times b to the 1. What's that? It's Tuesday. It's just b, right? The a's cancel, and b squared divided by b is just b. So you can just take a ratio of successive terms, right? And so in this case, that's going to be 64 divided by 80, which I guess is 8/10. So that should also be f of 3 divided by f of 1. Sorry, f of 2, right? Just a times b cubed times B, so that's also B, right? But in this case, that's gonna be 51.2 divided by 64. So are these the same? Hard to say, isn't it? So I guess we gotta do long division. Just, how many times does 64 go into 51.2? 0. 8? Yeah, in fact, exactly, right? So yeah, these are the same. Does that mean it's exponential? Well, we still have to check the last data point, right? So it's f of 4 over f of 2, sorry, f of 3, is that also 0.8? Well, we gotta check. 40.96 divided by 51.2, which is, I guess, 512 into 409.6, and 8, oh, sorry, 8, 16, carry the 1, 9, 40, yeah, so it works out, right? So they're all 0.8. So your growth factor is 0.8, and it's steadily, it's actually a decay factor, properly speaking, right? But it's getting smaller. But so each successive, there we go. Each successive value is obtained from the previous one by multiplying by 0.8. All right, so this one is, in fact, exponential. Okay, how about this one? Is that linear? Well, let's see, we're going down 36 on the first go, but we're not going down 36 on the next go, right? 24 minus 36 would be negative 12, right? So I would say that's neither then. Yeah. Neither exponential nor linear. How do I know it's not exponential? Well, the ratio of successive terms is just neither. Neither. Okay, how about this? This one's linear, right? Obviously, right? The slope is what? Negative 20? Steady increments of 1 in x, steady decrements of negative 20, or decrements of 20 in y. So, yeah, that's linear. Okay, so what's going on here? Yeah, more of the same, right? Is it more of the same?